Hi, in today's session, you'll be able to apply geometric methods to create composite structures as solutions for design problems utilizing real world context. And also, uh, I'll be reviewing all the related rules and formulae. Okay, so, and these are the basic rules you have to remember. In my previous sessions, also, I mentioned that first you have to read and understand. Let me move this a little down. First one is you have to read and understand. Second one is make a plan, especially draw a picture, and then implement your plan, which formula you have to use, which rule. And next one is evaluate the answer, like whether does it make sense kind of thing. So let's go to the next page. The first question of the day. Find the cost of building a rectangular driveway. So you have a nice car and this is the rectangular driveway. So to park your car. So you can take to the garage. Well, um, find the cost of building a rectangular driveway. So rectangular driveway means actually you see on the surface the length and width, but it has to have some depth. Then only that settles. That will have strong foundation. Therefore, technically it is just assume that you are digging the soil, and if you check it, it looks like some thick rectangular prism, right, which has a length, width and height. Just let me try to, let's say that this is the path from sideway, so this thick and oh, could be too long. Okay, so let's say that this is the path. Oh, it's not a straight line. Well, so this is how this is to be built. Okay, now this is giving me an idea of a rectangular prism. Prism. So what is the volume means? You know that it is length times width times height, right? So volume equals to, it is length times width times height. So let me plug in those values. 3 inches thickness, thickness means that is giving me the idea of the height. So let me plug in 3 here. And next, length and width are given as 9.5 and 21. Therefore, let me take the longest one, which is 21, and width is 9.5. Thickness is the height. Now, let me grab my calculator and compute, which is 21 times 9.5 times 3. That's giving me 598.5 cubic feet. Okay. Next, coming to the cost, you know, when you plan to go for any kind of construction, obviously we have to spend some money for constructing that part. And here the cost is $6 per cubic foot. So one cubic foot, one cubic foot equals to $6. And how many cubic feet just now we got means you know that it is 598.5. 598.5 cubic feet of volume we got. Then how much is this? Several times I explained this example that if you take let's say the cost of maybe one burrito is let's say $2, then what is the cost of three burritos means? In fact, you may use your fingers and you may say that one burrito $2, two burritos $4, and three burritos $6, right? Or else simply you may multiply three times two to get the answer. In the same way, 1 cubic foot is given and you are asked to find more cubic feet. So, what to do means just like our burrito example, just you may multiply these, you may multiply these. Okay? Right. So let's multiply 598.5 times $6 using calculator. So let me take 598.5 times $6. It is 3,591. Oh my gosh, is it that expensive? Could be, I'm not really sure. Is it that expensive or not? $3,591. So this much you have to spend almost $4,000 to get that kind of a ramp. Okay. Now, in today's session, I will not be asking you many questions because I have to cover a lot. Okay. So let me go to the next question. Wow, Pringles, my favorite chips. A cylindrical carton of family pack chips with a radius of 12 inches is 5 inches in tall. Please remember these numbers are not really correct. Just some numbers I typed randomly. So, a cylindrical carton of family pack chips with a radius 12 inches. Therefore, here the radius is given as oh my god, it cannot be 12 inches. So, I'll do one thing. Let me change this number to maybe 2 inches. That makes sense. Okay, so let me take that distance as 2 inches. Please notice that I changed the numbers. And 5-inch tall. So 5-inch tall means I would say that that is the height. That's the height of this one. Okay. If all surfaces except the top, please notice that except the top are made of cardboard. How much cardboard is used to make the chips carton? Assume no surface overlap. Round your answer to the nearest tenth. Let's assume that this is our chips, cylindrical chips holder, right? You know, the entire thing is made of carton, but when it comes to the top, you know that it is made of mostly the plastic. That the lid is made of mostly either a thin metal piece or maybe some plastic. So he says that except the top means please notice that we are not going to count the lid. We are not going to count the lid. So let me keep this net aside. Now, how will you compute this one means please notice that this round part which is called as curved surface, please notice that this is the curved surface, and also this is the base is also made of cotton. Therefore, I have to compute the area of this one and area of this curved part. Okay, so uh, let me write that first of all area to be computed equals to curved surface curved surface of a cylinder plus area of base. You know that area of base, this one is in the form of a circle. You see that it is in the form of a circle. So let me address that point also. This is in the form of a circle. Now, what is the curved surface area formula means? It is 2 times pi times radius times h. And what is the area of a circle means? You know that area of a circle is it is pi times radius square. Pi times radius square. Now let me plug in these values that radius is given as 2 inches, radius is given as 2 inches. So wherever radius comes, then I have to take 2 there. Therefore, uh, 2 times pi value is 3.14, and here radius is given, which is supposed to be 2 inches, and what is height means tall means that is height, or else from the diagram you can see that this is 5-inch tall. Okay, so times 5, this one plus pi value is 3.14 times radius already we noted here, that is 2 inches. So radius square means 2 square. Now let me grab my calculator and compute really quick on this. 2 times 3.14 times 2 times 5, which is 10, plus 3.14 times 2 square. Okay, so 75.36. 75.36. Anyhow, we are computing the area. We are computing the area. Therefore, 75.36 square inches. Again, if you Google it, then it may not match with my answer, because the paper required or maybe the material required could be different, but some numbers are taken randomly just to make a question. Okay, so let me move to the next question. Find the In the given figure, find the values of x, y, and z. So I see that first of all, remember, even yesterday also I mentioned L shape means 90 degrees. Please remember, L shape means 90 degrees. Therefore, here I see that L shape. I see that's L shape, right? We call it as perpendicular. If you want, I can say that here A, B, C, D. Okay. May I say that AB is perpendicular to BC or not? Perpendicular means, please remember, 90 degrees, or as I mentioned before, don't forget the L shape. L shape means 90 degrees. Therefore, here AB is a perpendicular symbol to BC. Therefore, angle ABC equals to 90 degrees. L shape, don't forget. So, may I say that when I combine these two angles, these two together makes 90 degrees or not? Mm, that makes sense, because see, this angle, which is 72 degrees, and angle x, you know this part and this part, these two together makes 90 degrees, right? So let me write that 72 degrees plus x equals to 90. Now here onwards it's easy. We go for inverse operation, that is take away 72 on both the sides in order to isolate x. Then after the cancellation, x equals to 90 minus 72, it is going to be 18 degrees. We solved just only one part. We have to figure out two more, y and z. Again, I see that line segment DC and BC, these two are perpendicular to each other. This time, again 90 degrees with L shape, not exactly L. This is L and this one is moved this way. So, this is also 90 degrees. Okay. Therefore, DC is perpendicular to BC. Let me write. DC is perpendicular to BC. Therefore, angle DCB is 90 degrees. DCB equals to 90 degrees. So, I see that it is 21 degrees. Yes, it is. So, 21 degrees plus y equals to 90. You know how to eliminate this one. You know how to isolate y. So just take away 21 on both the sides. When you do that, 21 take away 21, y equals to 90 minus 21. Is it 69? Correct me if I'm wrong. Yes, it is. So the value of y equals to 69 degrees. Now, the last part, how to figure out z, how to figure out z. Friends, please notice that x, y, and z, these three are the angles of a triangle, right? So, I hope you remember that there is a relation among all the three angles of a triangle. I hope you remember that that is sum of three angles, sum of three angles of a triangle is oops 180 degrees. 180 degrees. Therefore, I see that there are three angles. One is x, one is y, and the other one is z. Therefore, sum of these three angles means I would say that x degrees, y degrees plus z equals to 180 degrees. Now, what are the value of x you got? What are the value of x you got? That value, and what are the value of y you got? This value, please bring it here and plug in, then you get the answer. So I know that x is 18 degrees, y is 69 plus z, I don't know, equals to 180. Let's sum up 18 and 69. Is it 87? I guess yes. Yes, 87 plus z equals to 180. Now you can isolate z by subtracting 87 on both the sides. So the value of z equals to, is it 93? 93 degrees. So my apologies that this one seems to be less than 90, but all these numbers are taken only for the sake of calculation purpose. So please excuse me for that minor mistake. 93 means I know that it is obtuse angle, but when you look at this diagram, yeah, it seems that this one is a little less than 90. I'm sorry for that. Well, questions please, really quick. Okay, let me go to the next one. Here, two tissue boxes are pictured below. Again, what are the measurements are given? These measurements are may not be accurate when you really take the real world scenarios. These are just some numbers are taken to give you an idea how to compute. Two tissue boxes are pictured below. Each company has to pay for the printing that gets put on the package. If the tissue company has to cover the sides of the top of the box, so let's take this box. Do you see that here it is, there's name printed, and here, let's say that here, and here at the bottom also. Okay, so here, if the tissue company has to cover the sides and top of the box, and the other company covers the lateral surface, which a company has the lower cost in printing. So we have two scenarios. First one is the box kind of tissue pack, and the other one is the type cylindrical type. So it's the cylinder. So what do you compute means, suppose here if it is to be printed, I have to compute length times width to get the area of this, right? Therefore, area 1 equals to length times width. Length times width. Let me take the numbers which are 6 and 3, right? Therefore, let me take 6 times 3, that gives me 18. And next, the second part is they're printing on the sides also. I know that this is length and this one is the height. This is the height. Does it make sense? This is the length and this one is the height. Therefore, here they are printing. So, the other area is length times height. So what is the length means? I see that 6 units and height is 1. Therefore, I would take 6 times 1. Hold on. Here 6 times 1, and at the back again we have to take 6 times 1. So how many times am I taking? 6 times 1 means the 2 times, right? See, I have to compute this one, and behind this one I have to compute again. Therefore, 2 times I have to compute this area. Therefore, let me take that it is 2 times this one. Therefore, what will you get means 2 times 6 times 1, that gives you 12 units. I'm done, because the question says that the company is printing here, okay, but we missed here because all these sides. I repeat, read the question. The company has to cover the top. Yes, I computed. And next, and the other, sorry, if the tissue company has to cover the sides. Sides means all the 4 sides. But I told you that this part and this part are computed, but this part is missing, right? So how will you compute this one means, if this is the box, this is the length, and this is the width. Therefore, width times height we compute, right? Therefore, the next part is width times height. So what is the width means? I see 3 units. What is the height means? 1 unit. Therefore, it is 3 times 1. And how many times means once here, and again the same thing width times height here. Therefore, how many times means you have to compute 2 times. Therefore, the result is to be multiplied by 2. Therefore, you get that 2 times 3, 6, 6 times 1, it is 6. So I'm done, and let's compute what is the total area, which is 18 plus 12, that gives me 30, 30 plus 6, 36. Therefore, what is the total area means this is 36. Anyhow, we are computing area, therefore, square inches. Now let's focus on the cylinder. So cylinder here, it is mentioned that it has to cover only the lateral surface. That means the curved part. Okay. Already I explained that curved surface area equals to 2 pi r h. 2 pi r h. Therefore, it is 2 times pi times radius. This is the tricky part. This is not the radius, this is the diameter. Again, I'm repeating, this is the diameter, this is not the radius. Radius is half of the diameter. Half of the diameter means half of 2, that gives me 1. So let me take that radius is 1 unit, and what is the height means you can see that is 5 inches. Well, 2 times 3.14, that gives me 6.28 times 1 times 5. So you may compute, you'll end up with 31.4 square inches. Now the question is, you please compare these two, that the first company has to print 36 square inches to make the box, and the second company has to print 31.4 square inches. So which company has to print a less quantity or less area? Then for them the expenses are low, then they make more profits. So which company has a lower cost of printing means the second company, which is the company which is making the cylindrical tissue boxes. Okay, all right. Let's go to the next one really quick. Okay, this scenario is, just let me use my manipulatives. First of all, this problem can be solved in two different ways. I'll take the easiest way. Okay. First of all, try to understand what is the relation between a cylinder and a cone. Oops, my apologies. If you take a cylinder and cone, okay, which are having the same base and same height, please see that these two are having uh, the cone is a part of the cylinder now, right? If they are having the same height and same base area, that means both are in the same circle, right? We discussed in the previous sessions that volume of cone is one third. Volume of cone is one third, right? Now, assume that there is a cylinder, and a cone is carved out. That means a cone is removed. A cone is removed. When a cone is removed, what is left means the remaining part you can see in the diagram that which is marked, which is highlighted in dark blue color, right? Therefore, let me compute this one. What is the volume of the remaining solid? The question is, what is the volume of the remaining solid? Okay, so let me write that volume of remaining solid, volume of remaining solid equals to volume of cylinder, volume of cylinder, take away volume of cone. So what is volume of cylinder means? It is pi times radius square times h. Take away volume of cone means, please remember volume of cone is one third pi r square h. Okay. I'll explain in two different ways. One is the direct method, in which pi value is 3.14 times. What is the radius means? You can see that it is 3 centimeters. So radius square, that gives me 3 square. What is the height means? It is 4 centimeters. Okay. Take away one third pi, which is 3.14 times. What is the radius means? It is 3 units. So radius square is 3 square times. What is the height means? It is 4. Okay. So here, let me take my calculator and plug in the values, uh, which is 3.14 times 3 square times 4, subtract one third one third of 3.14 times 3 square times height. So that is giving me 75.36. That is giving me 75.36 cubic centimeters because we are computing the volume. Actually, this one seems to be little difficult. Can you say difficult? Okay, I'll take another easy method. The same question. Actually, I copied this one again. Okay, let me give an example. Suppose there is a pizza and this is cut into three pieces. Okay, and from the whole pizza, okay, if I take one piece, you know that this is nothing but one third, right? From one whole pizza, if I take away one third, what will be left? It is simple that there is two-thirds of the pizza left, right? In the same way, from the whole, if I take away one third, because you know that volume of a cone is one third, right? If I take away one third, can I say that two-thirds is left, right? Now, going back to the previous page, from the whole 1 pi r square h, if I take away one third pi r square h, just like our pizza example, see 1 pi r square h, take away one third pi r square h, what is left means, please remember the dimensions are the same. So you are left with 2/3 pi r square h. This is what we are left with. So 2/3 pi times what is the radius and height means, just you plug in those values. Radius is here 3 square times what is height means 4. So 36 12, then you may compute using your calculator. Most of the time some people prefer to leave the pi value as it is. Okay, 36 12. Then you get that 24 pi cubic centimeters. Okay, so you may get a doubt, is it matching with this one means, you may say that no, they are not matching. Actually they are matching because I expressed the answer in terms of pi. Sometimes you can based on the options given in the question, you have to change your calculation method. So I'm taking my calculator. The 24 pi means 24 times 3.14. That is giving me 75.36. So, basically these two methods are giving me the same answer. Here, lot of calculations. And in the second method, I know that I have given a simple example that one pizza, take away one third pizza, then you are left with the two-third. Then two-third pi r square h, just plug in the numbers. Okay, so let me go to really quick to the next one. Okay, as a part of her interior design job, Mrs. Baya has been tasked with painting two walls of a customer's dining room. Okay, the paint comes in right circular cylindrical containers and can be purchased only for either $7 per quart or $12 per gallon. A 1 gallon container of the particular paint covers 225 square feet. The two walls of the dining room she needs to paint are both 10 feet high and 15 feet long. Okay, so let's take a wall, two walls. Let's take a room. Oh, Let me draw a nice one. Okay, this is the technique to draw a 3D figure. You draw two rectangles first, then join these corners. You get that. Oh, the diagram is not so great. Oh, I see that the walls are at a different size. Well, suppose if you are asked to paint two walls, let's say that this wall, this side wall, and this side wall, these two are to be painted. So first of all, let's compute what is the area. I see that the dimensions are given that uh, length is 15 and height is 10, both the walls. So area of wall equals to length times height. Let me plug in these values. 15 times 10, that is giving me, they're given in feet, therefore 150 square feet. Okay, but we have two walls, therefore I'm not going to compute again. Please remember, not one wall, there are two walls. So for the second wall, again the opposite one also will be having the same measurement, therefore this is also 150 square feet. Okay, so what is the total area means? You know that the total area is 300 square feet. Total area is 300 square feet, right? So again, really quick, this is one wall, this is one wall area, and this is the second wall area, because these two are having the same measurements, therefore the same area. So these two together, that total area is 300 square feet. But suppose assume that you are the administrator, that means you are doing the business. A 1 gallon container paint 225 square feet. So if I buy a 1 gallon tin, can I paint both the walls? Because this one can cover only 225 square feet. Okay. Whereas how much paint should be purchased? Uh, 7 per quart. Okay, 225. So how to compute means we need more than 225. That means that is a 75, right? Another 75 is the shortage. In such case, if you buy a by gallon 1 gallon 1 quart paint, so what will be the area covered by 1 quart paint? I repeat, 1 gallon is 225. 1 quart means, I hope you know that 4 quart makes 1 gallon. Therefore, 1 quart means 225 divided by 4. So let me compute 225 divided by 4, 56.25. Therefore, if I take a 1 quart, if I take a 1 quart, a smaller one, this one covers only 56.25. Now, what will be your choice? Obviously, we have to take a 1 gallon, because the bigger one is at lower price. This is costing $12, and this one is costing $7. So, how do you purchase? Please remember, we have to cover 300 square feet. 1 gallon is not sufficient. 1 gallon, 1 quart is also not sufficient. So, do you buy 1 gallon and 2 quarts? In such case, if you buy that way, 1 gallon is costing $12, and 2 quarts means because if you take one, 225 plus 56 not sufficient to paint both the walls. So will you take this way, or will you buy 2 gallons? Does it make sense? 2 gallons, 12 and 12. This is 1 gallon, 2 quarts. Okay, if you sum up which is the best deal means for sure we go with this one, we go by 2 gallons, right? So what is the option means anyhow, this is how you have to compute. Again, I'm repeating from the beginning. I computed area of walls, I computed area of walls, which is length times height. Two walls means the same measurement, 150 and 150, that makes 300. Then 1 gallon paint that covers 225, which is not sufficient to cover 300 square feet. Therefore, what to do means if I buy 1 gallon and 1 quart, is it okay means still we are unable to paint 300, because 225 plus 56 is not equals to 300. In such case, if I buy 1 gallon and 2 quarts, then it is becoming more expensive. Okay, so if I buy 2 gallons, yes, I can paint it. So please don't memorize. You have to put everything and you have to check in real life scenarios. Okay. Okay, guys, that's it from me. Please revise carefully. Remember, all the formulae, always, it's a good technique that take a piece of paper and make a list of all the formulae. Don't be in a hurry. And yes, in real life scenarios, we use geometry a lot. Okay, so practice as many questions as possible, right? Okay, that's it from me. Bye.